Hi, welcome back. So the next example I want you to have a look at for me is this. This could be a starter activity that I'll normally set at the beginning of the lesson. So I would say, here's your question. Can you pause the video please and work through it? And when you're ready, unpause the video and watch how I do it. Right, welcome back. So obviously it's a tree diagram question, but what's the difference with this tree diagram question? I'll show you what the difference is. Jim selects a sweet and then he eats it, as you do. When someone offers you a bag of sweets, you don't think, oh yes, that looks nice, pick one out and then put it back. Particularly with coronavirus, okay? You don't want to do that. You probably don't want to offer sweets to strangers anyway in the coronavirus situation, do you? Anyway, enough of that. He eats it, okay? So the probabilities are going to be different. Well, let's just check out the tree diagram, see how that's going to work. So first of all, we've got what Jim is selecting, and there's either red or white sweets, and you've got 3/10 probability of getting red and 7/10 probability of getting white. I'm hoping you're fine with that. And then what Anne is going to do, so Anne, she is going to she's either going to select a red sweet or a white sweet, isn't she, in both cases. But the probabilities of these is going to be interesting, okay? So if Jim selects a sweet and it's red and he eats it, there are only 2 red sweets left out of a total of 9. So I'm hoping you're happy that the probability that Anne will select her red sweet is 2/9, okay? Now, if Jim's first selection was red but Anne chooses white, because all 7 of the white ones are still there, out of a total of 9 that's left, the answer will be 7/9. Remember to check your answers by making sure the pair of fractions in each branch add up to 1, okay? And they do. Next, what if Jim chose a white sweet to begin with? Well, if he chose a white sweet, then Anne is going to choose a red sweet with a probability of 3/9. I'm hoping you're happy with that. And she'll choose a white sweet, the probability of 6/9. Again, I'm hoping you're happy with that. Okay. This is sometimes called conditional probability, but it's also called probability without replacement. Okay. I'm going to just write that down here. So you're often looking for in a question whether someone is replacing something or not. And trust me, I know this for a fact. Even the very best students I've taught sometimes mess this question up. Okay, I did not want that to happen to you. Right, moving onwards. Okay, part A, probability both selected a red sweet, so that's this case here. I'm hoping you find this bit easy now. 3/10 times by 2/9. The answer is 6/90. And then the next case, they each take a sweet that's a different colour. So either you've got red-white, which is 3/10 times by 7/9, which is 21/90, or you've got the other way round, which is white-red, and that is 7/10 multiplied by 3/9, which is also 21/90. Notice, even with the without replacement question, the probabilities of these two are the same. Okay. Add them together and you get 42/90. I'm just going to put an additional question. What is the probability they both take a white sweet? Well, of course, that will be this case down at the bottom, 7/10 times by 6/9, which is 42/90. And just as a check, you can add these fractions together and they do total 1, so the whole diagram must be correct. I'm hoping that made a lot of sense to you.